Hello, I am Nick Harris, and today I will be walking you through how to build each one of these parts and then assemble them together and do the drawings. We will start with the base of the piece, and we will make a 3-view drawing of this. Then we'll do the shaft, the drawing. We will do the roller, the drawing for that, the support column, the drawing for that, and then finish by assembling it all together. And this will all be done in Autodesk Inventor. Okay, so we will start here. We'll start from the home page. So whenever you open up Autodesk, this is what you'll see. You want to go to new. To draw a part, you want to use just the standard IPT. The sheet metal is has different functions that is not necessary for doing anything that you'll be doing here in your class. So whenever we go to assemble everything together, we'll use assembly drawing. Whenever we make our 3-view drawings, we'll use an IDW file. Okay, so we'll start with standard IPT. You just double click it to open it up. So whenever you first open up an IPT, you'll see a blank workspace here. And the way you want to start most things is you start a 2D sketch. So then you want to select the plane in which you will be drawing your sketch. So the way we will do this is we will start by drawing this face and then extrude it out here and then add 4 holes. So if we go back to our new part, we will start right here onto this plane. You see it highlights the plane you want. Click it. Okay, so then it takes you here into sketch mode, and you see that it automatically moved us to the sketch, the settings. So we want to start here. We will draw a rectangle here that is centered around the origin. To do this, we can go to our rectangle and our drop down tool. We want to start from the center. So this one, what it will do is allow you to click the center of your rectangle where you want it, which is where the origin will be, and then you can drag it out. And now here you can type in your dimensions now. As you can see, it's highlighted that one, and you just press tab to do the other dimension. But we'll just click it down so we can show the dimension tool. So it will just create a rectangle like this. All right, so now we want to start. So these are dimensions that I have here with me. So this is 3/8. So all I did is dimension tool, I clicked this, or you could click both of these and drag it out. You're not holding it, you just click it and then click it down again. So then the total length we'll do, so I click this, and click that. This is 6 1/4. So you use the mouse wheel to zoom in and out, and then you hold down the mouse wheel to pan around. Okay, so this is our first square. Now, what we want to do is add another rectangle on top of this, like this. So now, what this will be this piece right here. You can see we're drawing this in right now. We already have the base of it drawn. Okay, so this dimension here is 5 3/8. And you can do math inside of these dimension tools, as you'll see a lot during this video. 1 5/8. Here's our total dimension. Now, as you can see, it is not centered on this top rectangle. So what we can do is we want a dimension from here to here. And here's a very useful function. So like I said, you can do math. You can also do math dependent on other dimensions. So we want to say that it is this dimension minus this dimension divided by 2. Oh, it is centered on this. And now we just need one more dimension right here. This is a 1/2 inch, but it's not. 1/2 inch minus 3/8. There's the height. And now, one last thing we want to do is trim out this line that is in between them. So we go to the trim tool, and you can see it will highlight in dotted line what you will be trimming. So we trim that, and remember there was 2 rectangles there, so there's 2 sets of lines. Just click it again. Okay, so we cannot do that because we have a dimension dependent on it, which is this dimension here. So if we go ahead and trim this first, then it will go away, and we can dimension this again between there. Okay. All right, so then we just click Finish Sketch, and you'll see it'll zoom in on us. If we just zoom out, it'll be fine. We extrude now. This needs to come out a distance of 3 1/8. Now you can see that we are pretty much done with this one. We just need the 4 holes, which is very simple. So we will start a new sketch on this face. We will add 4 points. Actually, no, we will add 2 points here, and then I will show you the mirror tool. So what we will do is we will draw the 2 points here and put them where they need to be, and then use a tool called the mirror tool to just copy them over to this side. And we need a line to mirror them about. So this marker right here is called the construction tool. What it does is it makes any line or circle or any shape that you make not applicable to the drawing. It's just to help you with dimensions. So now, since we're on this, we can't see it. If we hit F7, or we can go to View and Slice Graphics, what that does is it just cuts to the plane that you were working on. So you can only see the plane you were working on. So now we can see it's a dotted line. That means it is a construction line. This means you cannot extrude or do any 3D shapes off of this line, but it is for dimensioning or for mirroring these parts. So now we want to dimension the size between these holes, which is 2 3/8. And once again, it will not be centered. So we want to just put this line down. And so now what a driven dimension is, it means that we can't edit it, but it is a true dimension. So it'll put it in parentheses. That means that this is not a dimension you can change, but it's a dimension you can reference. So now another thing that you might notice is that it is possible that whenever you put this dimension on, these dots were no longer in line with each other. What you can do in that case, you can see that we are looking from the top. The top is over here. So we need to use the horizontal constraint tool. So all these are constraints. They just make it so that your lines and dots can't move in certain ways. So we want to use the horizontal. We'll click this dot and this dot. What that does is make it so they always have to be in line with each other along that axis. Okay, so now we want to make sure that these are centered. So just like we did last time, we'll put parenthesis, this minus this divided by 2. Okay, and now the last dimension we need is from here to here, which we will just make equivalent to this. Okay, so now the last step we need to do in the sketch is mirror these over here. So if you hold Control and select both of these dots, it will highlight both of them as you see. We can go to the mirror tool, which is right here. And now, since we already have these highlighted, they're already selected, we do not need to select anything else. We go to the mirror line, and that is the line we drew in the center earlier. We click that, and then you click Apply, and you can see that it moved these guys over here. Okay, so now we finish the sketch, and we use the hole tool. So you can see it pulls up. It automatically selected them. If it didn't, you would just use the input geometry and select the points that you wanted to do. We do not have a seat or anything, so we're selecting the seat. We want to go the whole way through. So it's a simple hole, the whole way through here. Otherwise, you can tell it to go down a certain distance. You can tell it to go to a certain plane, but we are just going the whole way through. You can change the direction in which it is traveling. You can make it go both ways. We're just going straight down here. And this hole size is 5/16. You can see it automatically updated all of them. You click OK. And there is our first part. So now we want to save this. So you go to File, save as, locate the file, the folder in which you wanted to put this. We are just going to create a new folder. Okay, go into this, and we will call this the base. Okay, we'll call this base inventor. And just double check that it is saving as an IPT file. You want to click save. Okay. So now you see it updates. This part is saved. It is now saved. So now we want to do a drawing of this. So this is how the drawing should look. We want to have the three views since the three sides are all important, and then an isometric view. Okay, so we will go to, you want to go to File, New, and now this is an IDW drawing. So you'll double click this. And now you can see that this paper size is too large. It's using size D. We need to use size A. So if you go over to the sheet and right click on it and go down to Edit Sheet, it'll pull up a menu. You can change the orientation of the paper. You can add the revision. Like if you revise a part several times, you can change the name of it. But all we are interested in is the size. We want to change to A. Okay, so now you can see it makes it smaller. So now we want to place down our views. So we click base. So now this will pull up the last drawing we were using, which is base inventor. And we want, so now this is doing it from the front side. I think it will look better from the left side. So we just use this cube to locate the side of the drawing we want to look at. And you just pull your mouse above it, click it down, it'll do that view, this view, and isometric view. It's that simple. So now you click it down and you want to put dimensions on it. So you want to go up here and select annotate. So now you can see there's a lot of options here on how to do it. You have a specific one for holes. So let's use that one. So now this only works if you use the hole tool. If you extruded a circle through this, you cannot use this tool. Okay. So we just click that and place it down. And now to indicate that we used that this is for all four holes, we just can double click onto this thing here and it'll bring up the menu for everything. We can just say 4 times. So now what that says is that there's 4 holes that is this dimension and they're cut all the way through. Okay, so now we can place some dimensions on here. So it's the same idea as the sketch before. You just click the dimension, click the sides you want to dimension. This will come up with a little window where you can add tolerances and stuff, but for this, we're not going to worry about that. And now this takes a lot of practice to be able to put the dimensions in the right places. So whenever you do this for our class, do not worry too much about having everything perfectly dimensioned, because we will also have your part file. This is just something you will work on over time, is learning how to dimension everything. Okay, so I'm not going to spend the time to dimension everything, but I will show you the center line tools. This is very important in drawings. Whenever you have circles, you want to use the center mark, and you just click the circle. It'll put a center mark on it. And then down here, with where you can see that the holes are shown there, you want to use the, this will put a center line between 2 lines that you choose. So we zoom in, we want to click this line, and it'll put a center line through. You would do that for all of them, or anything that is symmetric. You want a center line. Okay. So I will not walk you through every dimension that you need, because it depends on each drawing. It's also a little personal preference of where you put the dimensions. Okay, so next we will be doing the shaft. So now if we look at our main assembly, this one is what holds the roller in place. It's right here. Right, so that brings us to this. So we will build this next. It almost looks like a little rolling pin. To do this, what we will do is we will take a cross section. I'll show you. So we will draw this cross section without the chamfers, which is these cuts out of the sides. And then we will use the revolve tool to make that plane circle around and make our whole object. Okay. So let's go to, again, to File, New. We are doing a standard IPT file. Okay. So we will start a sketch along this plane. So now we need to draw, we will be drawing a shape like this. But a shortcut to where you do not have to dimension this entire thing is we will just be drawing this section of it, and then we will mirror it over this line. So to start, we will put a construction line along the vertical axis as well as the horizontal axis. This is for referencing later. So now we want to make sure you leave construction mode, otherwise you will not be able to revolve or extrude anything you make if you are still in construction mode. So we will start with the line tool. We'll start here, and we will come out a distance of 4 3/4 divided by 2. That is the total distance, total length of the shaft divided by 2. And now we will come up a distance of 7/16 divided by 2, which is 7/32. Again, this is the smaller diameter of the shaft in half. Okay, and now we will come in a distance of 11/16 and then come up a certain distance that we will define later, and then finish it off back at the vertical axis. So to dimension this line, it would be simpler to dimension from this distance, because we know the total diameter of the shaft, which is 3/4 divided by 2 would be 3/8. Yes. Okay. So now, in order to mirror this, we will highlight these points. So if you drag from this side, you'll see that it's red, and that'll deselect items. And if we select from this side, either way, it'll select items that are being highlighted. So we select all these, we use our mirror tool. We will use a mirror, select the mirror line as we have already selected all of our points, and apply. So now we will finish the sketch. We will choose revolve, and you see it already selected the plane. If it did not, you click this and select the plane. If for some reason it can't find the plane, go back into your sketch mode and just make sure that all of these corners are connected, and at all adjoining points, everything is completely connected. So now we need to select the axis to revolve around, which is here. You can see it made our part. Okay, so now the one thing we need to add are chamfers here, 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 and here. This is very simple. It's just a tool. You select each of the corners you would like to chamfer, and then you would change the dimension. I believe we used 1/32. Yes. Now you can see the shaft is built. Okay, so now we will save this part. this is Inventor. Save. And then for this part, when we move to our IDW drawing, and don't forget to change the sheet size. So now, as you can see for this one, if we were to do a 3-view drawing, these 2 views would be the exact same since it is just a cylinder. So this view is unnecessary. We can just have 2 views. And then the isometric view. So now what is nice to do in these situations is to change the scale size for this, as there's a lot of white space on this page. So if you double click this, it'll bring up this view. We want to change this, use the drop down, change it to 1:1. And you'll see whenever we click OK, it'll automatically update this view. This view should remain the same. Okay. So now, again, this will just be dimension. You want to start with center lines on this. Whenever they are not long enough, as you can see, you can grab it and extend it. You want a center line on this. And now whenever you go to dimension this, you will want to indicate that it is diameter, which this already has, as you can see. And whenever you go to show the chamfers, there is a chamfer dimension tool. You click that, you select the chamfer, and you select the axis, or the other line of the thing, and it'll automatically make it a chamfer notation. Okay, so now our next part we will be building is the roller. So now, as you can see in the assembly, this is the main part. This is where a belt could be on to roll around. Okay, so this one is more complex of a part, as you can see. So, but we will follow a very similar idea as to what we did last time. So again, I will show you the section that we will be drawing around. So we will be drawing this here. My apologies. We will draw this. This will be our vertical axis. We will draw this part of it, and then mirror it over and revolve it about the central axis here. Okay, let us begin. So we will go to File, New, Standard IPT. We want to start a new sketch again. We'll go about this axis. Okay, and again, we will start by adding construction line along the vertical axis. We will zoom out some so that this can be larger. Okay. And we will draw a line along the horizontal axis. Okay. So now this will be the point at which we will rotate about, is this line here, and it is hollow in the center, so we will come up a certain distance. It will come out. It'll go up. Ooh, and as you can see, I forgot to exit construction mode, so if you do that, you can highlight all the lines you did and unselect that. So you'll leave construction mode, and then we will leave construction mode. Okay, so now the line will come in. It will go up like this and like that. So now, just to be very clear, what we have drawn here is this shape right here. All right, so now we will enter our drawing again. So now we need to dimension this. So we will dimension this direction first. So this diameter is 3/4 of an inch. So we will call it 3/8. This diameter here is 1.5 inches. So we will bring that to 3/4. This diameter here is 1 3/4 inches, which you can just divide by 2. And this diameter is 3 1/4. And the last diameter is 4 inches, so 2 inches. So now this total distance here is 2 3/4, which we will need to divide by 2. And as you can see, that has made some weird errors happen, but it will solve itself. When we dimension this, so no, it will not. So what we need to do first, to know that distance, we need to put this distance in here now. And we'll start with the outer diameter. Okay, so this will be 2 9/16 minus 3/16 divided by 2. So this dimension was put in wrong. Oh, this dimension was not done yet. Okay, so these are some issues you run into with doing sketches. Is sometimes the lines will not. If you draw it too big at first, the lines will not agree with each other. So we need this dimension here, which will be okay. So the dimension I have is from here to here, which will need to be 15/16. And then this dimension will need to be 2 3/4. Apologies, I did not write it. 2 3/4 divided by 2. And then we will need to fix this dimension before we can do that. So this dimension here is 3/16. So now we will end with this dimension. So that might have been confusing, but as you can see, there's the problem solving. The process you need to go through. So whenever it is not working with you, you need to just go back a few steps and try again. Okay, so now we just need to mirror this over. So again, we will highlight everything, mirror across this line, apply. We will finish the sketch, and we will revolve. Again, it is already selected the profile. We just need to select the axis, which is here. And as you can see, we have drawn our roller. Okay. So now we will save it. We will start a drawing for it. We will change our sheet size. And we will need to place this down. And now again, as you can see, that these two views will be the same, so one of them is unnecessary. And then the isometric view. Okay. And now something that would be very useful for this drawing would be what is called a section view, which what it will do is it will cut a certain section out and it'll show you. So what you would need to do is select your section tool and then select the drawing in which you want to section. So you want to have it, we'll have it on the center of this, but you don't want to click right here. You want to go just above it to make sure you capture everything. You come straight down, you right click, continue. So now what you can see is it draws these lines here to indicate where the item is being cut for the section, and then this is your view. And it labels the section to what it is. So now you would do all your dimensions off of this. And again, I will not lengthen this video by putting all the dimensions in. This is something that is a skill that you really need to develop yourself over time. And just put the dimensions that you think are important, and we will discuss it in your meetings. Okay, so now we are on our last part, which is the support. So as you can see again in our assembly, this is this piece here, both of these pieces. It is what will hold the roller and the shaft up and sit on the base. Okay, so this shape will require more steps than the previous ones. As you can see, there's no simple way we can build this with one operation. So what we will do is we will draw this base without the holes. We will extrude it up. We will make this a rectangle right here. We will add these fillets in and fillet this to round the edge. We will add this circle out without the hole, extrude it out, and then we will add this gusset in here, and then add all three holes. Okay, so we will begin by starting a new IPT file again. Start a sketch, and we will do this one on the bottom plane as we will start from the base. Okay. So now, again, we will start with a center point rectangle. We will come out here, and now we will dimension this one. So this is 3 1/8. 1 1/2 inches. Sketch. We will extrude this piece up a distance of 5/8. And we will start a new sketch on top of this plane, where we will use a 2-point rectangle starting from this edge. down. We will dimension this to be excuse me while I give the dimension for that thickness. It will be 0.375. We will need this distance, which is 1 1/8. Now we will need to center this once again. So we will find the dimension for this, except that is a driven dimension. Again, this just means we can reference it, but we cannot change it. So now we need to have this distance, which will be equal to this distance minus this distance divided by 2. Now it is centered. So now we will extrude this piece up a distance of 3 1/2 minus 5/8. So you can see it is starting to take shape. Now the next step will be to fill it. So we will fill it this corner and this corner. The fillet radius is 1 inch. Accept this, hit apply. And now we will round the top edge. Select both edges. And now as you see, it will just cut it down to whatever the radius is. The radius for this needs to be 1 1 1/8 divided by 2. That it perfectly rounds the top. Okay, so now the next step is adding this circle. We'll start a new sketch on here. We will use our circle tool. And if we highlight this edge first, it'll show us where the center point of that is. This is where we'll start our circle and bring it out to the edge of this. It should have a diameter of 1 1/8 inches. We will finish the sketch and extrude this one out a distance of 5/8 minus 3/8. Now, as you can see, we have this part, the next piece extruded out. So now we need the gusset and the 3 holes. We will start with the gusset. If you go here to this folder that's called Origin, it has all the origin planes here for you. If you right click one of these planes and tell it to be visible, you will be able to see it. And you can see this is halfway through our part because we drew our center, our original rectangle at the center. So now we will want to start a sketch on this plane. And again, if we hit F7 or go to View and Slice Graphics, it'll cut it down to the plane we are operating on. Okay, so now we will want to use the line tool. This gusset will go from the edge here to a certain point along this line. We can dimension. A smart practice for pieces like this is if you just place it here along there, and we know that this point needs to be constrained to this point. So what this constraint here does is it locks 2 points to be at the same location. So we can say this one to this one. Okay, and now we need the dimension that this goes up, which is 2 1/8. And now we need to complete the triangle. Okay, so now we finish the sketch. We'll go to extrude. We will do a symmetric extrusion. So since we are about this line, we want this to be even on both sides. So we will do symmetric. You could also do an asymmetric where you have to define both distances. we will just do asymmetric. And this distance here is 5/16. Now that what the distance you insert into this whenever you do asymmetric is the total distance across the entire gusset here. It is not just from the plane here. It is from here to here. Okay. So now we no longer need this central plane, so we can right click it here, or we can right click it here and turn off the visibility. Okay. So now we just need our 3 holes. We will need to do this in 2 steps as they are not in the same plane. We can start with this one. So start a new sketch along this plane, add a point at the center of this. So I just highlighted that to show where the center is, placed a point, finished the sketch. Use the hole tool. Again, we have no seat, we have no specialty hole, and we are going straight through. This is a diameter of 7/16. As you can see, we just inserted the hole there. We will start another sketch on the bottom. Insert our 2 points. We will tell them to be along the same axis again. We will dimension the distance between them, which is 2 3/8. We'll add this dimension so we can center them along here. So this will be this distance minus distance divided by 2. And it is worth noting that if you are not comfortable with referencing other dimensions, you could calculate what this distance needs to be by hand and just enter it in yourself. This is just a shortcut if you are comfortable with it. Okay, and now we will dimension the distance from here to here, which is 7/16. So you move them both down, we will finish the sketch. We will use our hole tool, and it is again 7/16 diameter going through. So this is already good. We click OK, and you can see we have our support. Okay, so now we want to save this part. Okay, save. We can start a new IDW drawing for it. Again, change the sheet size to A. Place our base down. So we will want to lower the scale here. And now if you change this after, it will still update everything. So again, you just want to have center lines of the holes and the symmetric parts, and then dimension everything. Okay, so now we will move into our final step, which will be assembling this into an assembly drawing. So we will go to File, New. This time we will be using a standard IAM file, which is just an assembly. Weldment is similar, but it will use slightly different tools. It allows you to put in information about welds if you're planning to weld something together. This is not something you will need to do at all in this class, so we just stick with the standard assembly file. Double click it to open, and now it'll bring you to this blank screen. What you want to do is place the files you have already saved. So if you go to this place tool, make sure you're using just the normal place. The content center is a catalog that Autodesk saves of different bolts and just standard components that you can just automatically add into an assembly without needing to draw it. This is not something you will need to worry about in this course. So we will just click place. We will locate the folder that we are operating out of, so Inventor Video. we will just highlight all of them, or you can do them one at a time and click open. And as you can see, it will place everything down at once. You just click them down. Okay, and now we need 2 of these parts, so we can do this just like any other thing. We click it, control copy, unclick it, control paste. Just control C for copy and control paste for paste. I believe you can also just right click and copy and then paste if you would choose to do it that way. Okay, so now what we will need to do is constrain this piece to be connected to here, this piece to be connected here, and join this as a cylindrical connection in between these, and this in a cylindrical connection to this. If you do not understand what this means, it will become clear here in a moment. So we will start with our constrain tool to place this onto here. So there's many different tools. There's mate, which will allow you to take 2 surfaces and connect them together. There is angle, which will allow you to put a certain angle between 2 surfaces. Tangent, which will allow you to connect a cylinder to a surface. And insert, which is the tool we will be using, which will be used to insert a hole, constrain a hole to another hole. So we will select the bottom of this hole and the top of this one, and you can see that it connects them together. Click apply to save it. Then we will select the bottom of this hole, and the top of this one, and you can see it turns it, and now this one is fully constrained. And one more thing you want to do is you want to take your base part, right click, and click ground. What this will do is it prevents you from being able to drag it or move it anywhere, which just keeps your drawing centered at the origin. It keeps the assembly centered at the origin of the workspace. Okay, so now we want to do the same thing for this one that we did to that. Constrain, insert, select this, apply, select this, apply. Okay, and now we want to do a cylindrical connection between these and this. So now constrain will hold something to where it cannot move from that location. The join tool allows you to do connections where 2 objects are connected but can still move relative to each other in different ways. So there's many different ones. The ones we will need here is cylindrical. What this does is it allows an object like this to be able to move freely in and out of this. So we will select this cylinder. We'll change our view some. We will select this cylinder, and you can see it does a little animation to show you how it's able to move now. Okay, we want to click apply, and then we can also use a cylindrical connection here along this, and to be able to see the inside of that, we want to pull this out of the way. Cylindrical connection between this and this. Okay, and go ahead and apply. So now we can position this between them. Okay, and we can add a cylindrical joint between this main piece and the shaft and the roller. And it just does a little animation there to show you where it can move in and out of. Click apply. Okay, and now just add this here. So now we can see we have our total assembly, and this tutorial is complete. So the best way to learn how to do this tutorial can help if you follow along, but the best way to do it is to practice yourself. Just grab something that you have in your house, a water bottle or something, and just try to play with the different tools that Inventor offers and see how you can do it. There's far too many tools to be shown in a reasonable amount of time. The best way to learn is to just play with it. You use YouTube and just don't worry about messing it up. We are here to help you through this project. All right, so this is the end of the Inventor video. There's also a SolidWorks tutorial if you choose to use that program instead. I believe that is it. Thank you.